Beste bezoekers, welkom. Ik hoop dat u lekker gegeten heeft, de lunch. Ik zeker. Maar we kunnen het niet gezamenlijk doen helaas vandaag. Maar we zijn terug. 1 uur. Het is 1 uur. En om 1 uur gaat het over eenvoudige en snelle toepassingen van safety-communicatie in maatwerk besturing. En deze sessie zal plaatsvinden in het Engels. Boven mij ziet u al die kant. Koert. En Stuart. Stuart is Engels. Koert is Nederlands. Koert neemt het van me over. Ik start de presentatie en aan jullie het woord.
Okay, right. Well, good morning, everybody. My name's Stuart Hanna. I'm Technical Sales Manager for the UK area for Anybus Embedded Products and Safety. And this is my colleague, Kurt, who will get to introduce himself.
Hi, I'm Kurt van Buul, and I'm OEM Project Manager at the Benelux office.
Okay, right, we'll begin. We'll have a very short introduction to HMS networks to just set the scene. HMS was founded in 1908, based in a small town called Halmstad in Sweden. We operate in 16 countries with over 700 employees. We have distributors and solution partners in 50 countries now, and we have more than 9 million installed products globally. We're listed on the NASDAQ OMX exchange. So I'm going to introduce you to Kurt, who's going to go over some safety basics. And over to you, Kurt.
Thank you, Stuart. Every system has from nature a certain system risk. And with help of reduction methods like safety tolerance or redundancy, we reduce the system risk below a certain tolerated risk. And that means that the remaining risk will be in a normally safety area where a system is working normally. At the moment, this remaining risk tends towards the tolerated risk. We detect it, and with help of a safe state zone, we try to bring a system into a safe state. But please note, whatever we try to do, there's always be the possibility that a system, the risk of a system increases over the tolerated risk, and so entering into the danger zone. And safety management is all about reducing the chance a system is coming into this danger situation. Therefore, we have defined several levels of danger situation, starting with a level where we, when it would happen, we would have minor injuries up till SIL level 3 or performance level E, where you could have major or even death-threatening injuries. And although it's the possible failure is indicated in some small figure per hour, you could say that on the highest level, we accept approximately 1 failure every 1100 years. But besides defining such a level, it's of course also important to assign it. How do our customers know that we have set up a system which fulfills those rules? And depending on the level, the assessment is different. We're starting with an independent person, but on the highest level, you have to use an independent organization. And that's where organizations like the TÜV, IFA, and others play an important role. For the rest of this presentation, we will focus on the highest level, SIL 3 or PLE. I already indicated that we try to reduce risks by introducing redundancy. And in general, there are 2 different ways to do it. The first one is the homogeneous one, where you simply use the same solution twice. You also could use a diverse solution where you have several systems more or less doing the same approach. I also indicate that we try to bring a system into a safe state when it tends towards the tolerated risk. And the most common used solution is simply switching off the power of a system. Of course, there are systems where it's not so handy to switch off power. And in that case, we will bring a system into a safe operation. For the rest of the presentation, we will focus on homogeneous redundancy in combination of a power interrupt, because that's the common used solution within the industry. I hand over to Stuart for an introduction of safety communication.
Thank you, Kurt. Okay, let's look at some basics of safety communication, and we'll start with an example. So this is a typical machine application. We have a machine behind a light curtain. If the operator puts their hand through the light curtain, it will stop the machine. And if they hit the emergency stop, it will stop the machine. And it does that by a direct break of the power through these main contactors. The next choice we have is that because we're becoming increasingly networked, we could use safety nodes. So here we have a couple of nodes connected. One is connected to the machine. The other node is connected to the contactors themselves. In between, we have a safety PLC. If an event happens at the machine, that communicates the information through the safety node to the PLC. The PLC will then communicate that to the node once it's decided what action to take, which in this case would be break the power. Now, let's have a look at safe communications. Now, safe communications doesn't mean that it's always available communications, and that's an important thing to remember. If we look at this situation here, we've got a couple of communicating nodes, PLCs or machines, whatever it might be. They're talking over Ethernet and they're talking Profinet. And within them, we have protocol stacks that are handling the Profinet communications. Into there, we could add a safety stack. This would be to do safety through a software alternative. The safety stacks will talk to each other through what we call the black channel. And should there be any issue with the communications and with the machine will fail into a safe state. And this is the key thing here. What we're trying to achieve is safe communications via a non-safe network. It's not a case of guaranteeing always on communications. It just means that if anything goes wrong, you will be in a safe state. Now, we're using a mixed mode on here. So this is safety telegrams between standard telegrams. So here we have our telegram messages transmitting along the network, and we have our safety telegrams within there. If we take a bit of a closer look at that, we can see that we have encrypted safety data in there. When we break down that down further, we have a few key areas to look at here. We have what we call the consecutive number. Each message is given a number. It is a sequential number. It's not an infinite number, so they will loop eventually, but it's enough to ensure that the system knows that the messages are coming through sequentially and what order it should be processing them in. We have the safety source address and the safety destination address to make sure that only the correct nodes are communicating. We have a timestamp, and then we have the encrypted safety application data, which could be just something as simple as stop. And of course, we have a CRC check. If we look at the safety communication protocols, the safety protocols work on top of the communication protocols. So down the left, we can see we have ProfiSafe. That's associated with Profinet and Profibus, and not surprisingly is Siemens protocol. We have safety over EtherCAT. We have various flavors of SIP safety. So we've got Circos, ControlNet, DeviceNet, and of course Ethernet IP. And we have CC-Link safety. And finally, the open safety protocols, which will work with several different protocols we've already seen as Profinet, Ethernet IP, Modbus, Ethernet PowerLink, and Circos. One thing HMS likes to do is talk about industrial network shares. And this is just to really set the scene in terms of what protocols are being used. It's expected by HMS that the share of industrial networks will be 64% for industrial Ethernet and 30% for field bus, with wireless at 6%. If we compare that with 2019, you can see the change. Industrial Ethernet has increased. Field bus has definitely decreased from 35% in 2019, whilst wireless has remained stable. Okay, so I'm going to pass back to Kurt to talk about embedded designing.
Thank you, Stuart. And now we have discussed a little bit the principle of safety communication. Let's see how that how that can be embedded into a design-in. And therefore, I start with a standard application. You have an internet connection running a real-time Ethernet protocol like Profinet or Ethercat, and a CPU. And the CPU is running a protocol stack, the software to handle the protocol, and of course your target application doing your sensor checking and your control. At the moment we want to make this safe, we have to add redundancy, and that's done by simply adding a second CPU. And both the original and the second CPU will run a safety stack connecting to the protocol. So in this case, we are running over Ethernet Ethercat, and that means that we have fail-safe over Ethercat as the safety protocol. And as Stuart already indicated, via the internet connection, you get a mix of standard Ethercat messages and those special safety messages. And inside the original CPU, the special safety messages are sent through both safety stacks. And both safety stacks will open the safety containers in those messages, will check if the information is valid, and will come to a decision. And when they have made a decision, they compare to each other if they have made the same decision. And only if they have made exactly the same decision, they will keep the power of the system active. And which means that at the moment they make a different decision, or they have lack of communication because there are no safety messages coming in, then they directly will switch off the safety power relay. Please note that what Stuart already indicated, that you have communication over safe communication over a non-safe network. You see back in this design as well. The first part is non-safe, but the second part, where the stacks are taking over, is the safe part of the application. But if you want to certify this as a safety application, I'll come back to that in detail later, then you have to certify it as a complete system. We already discussed a couple of times using a software stack. But a software stack is not a simple application part of software that you buy in and add to your application, and that's it. It's rather a very complex, in detail software where you really have to understand how an application is working and which phases and technologies such an application all contain. At the moment you have set up a protocol and it's working, you have to do the complete certification. That means you have to set up document preparations, you have to do pre-confirmation tests simply to find out if everything is working okay. Then you have to bring everything to the latest software state, and you can send it to a certification lab to get it certified. The bad part of it is that you, in general, have to support more than only one stack. First of all, not all protocols are dominant in all parts of the world. In Europe, for example, Profinet and Ethercat are the most popular protocols. But in America, Ethernet IP is popular. And when would you like to ship your product to Japan, then CC-link E8 from Mitsubishi Electric is popular. That means that you have to implement several stacks for several solutions. And besides the stack itself, you also have to combine it and integrate it into your target hardware and into your target software. And besides the protocol, you also have to add the additional protocol stacks to support your safety. And if your application has to support IoT 4.0, you have to add those special protocol stacks as well. And to finalize it, if your product management is requesting for web browsing functionality, emailing, or whatever, you have to add all those stacks to your total system either. And the bad part of software, that is, it's simply not standardized, which means that all these stacks are coming from different vendors. They are using different structures. The interfaces are different, and unfortunately, they are not released at the same moment. Then, if you want to combine all those protocols, you have to understand that some of those protocols interfere with each other. And beside that, you also have to let them work all together in one real-time environment. That means that developing with multi-protocol software development is a very complex task. I already indicated a little bit about protocol certification. And the protocol certification is a right, straightforward process. You start to, you predefine it, you do your pre-test, you send it to a lab, and you get it back with the stamp that it's tested. Down the line, it's a completely technology-driven approach. But if you want to certify your safety application, that's much more difficult, because what you actually ask to a third party like the TÜV, would you please make clear to our customers that this system is really safe? And that means that the TÜV really wants to know that it's safe. And that's more than only technology. They want to directly see what not only the quality of your design is, but what is the quality of your organization. How do you process it? How do you document changes? Who is responsible for the setup? Who is responsible for taking care of the quality? All those items come back at step. And every change you would make on the design would mean that you have to start the complete safety certification from beginning of on. That means that a safety certification is a very complex task, and it is not technology driven, but much more process, quality, and organization driven. And that you see back in the development time. A simple protocol certification of a device running Profinet, for example, that will cost you approximately 3 months. A safety certification will cost you at least 1.5 to 2 years. To overcome those issues, Stuart will take over to present to you a much more modular design in.
Thanks, Kurt. Okay, let's have a look at the options against stacks where we use a modular designing and what are the benefits. So here we have an application. It's a motor control application in this case. This is our target application. So we want to add safety functionality to this without using stacks. Firstly, we use a pre-certified Ethernet module or communications module. That's going to handle the general communications. That will handle all of the standard protocols you're looking at there, including the Ethernet and the IIoT protocols. Next, we can add a pre-certified safety module, and I will be repeating pre-certified because that's key to this. We could also add a pre-certified power supply module. The safety module will be handling the safety protocol stacks, whilst the standard module handles the communication protocols. we can then add pre-certified input and output devices. So for example, we have this input switch, emergency stop, going into the safety module. And then from the safety module, we're communicating with the safety relay. Key thing to note here is that all the safety communications happens outside of your core application. So the central controller, this motor controller, doesn't see and isn't affected by the safety communications unless a safety situation occurs, in which case the safety module via the safety relay would break the power. Key thing here is that as well as the communications, the physical safety modules are all outside of the core application. So in the yellow area here, all of these modules are pre-certified, which is going to save a lot of time and money, because that's the part that you will certify rather than having to be involved in changing your own core application, such as a central controller system. Now, the next slide isn't there for you to read through. It's going to be in the notes. But all of these aspects are what you would have to do if you were managing this yourself. So if you were trying to develop the application yourself, these are all stages that you have to go through, which are all taken care of by using a pre-certified module and pre-certified technology. So you save yourself a considerable amount of time over implementing it yourself. So let's have a look at a customer case. This is a client of HMS's called Fortress Interlocks, so very well known throughout Europe. Fortress, as they say, are world-leading safety interlock manufacturers. And a few years ago, they realized that they needed to find a solution for safety communications too. So they started down the path of looking at developing their own solution. In this case, they started working with HMS on our module, which is called a T100 safety board. But the same argument applies for any safety boards. So this was saved them time and money by using a pre-configured safety board. They only then had to worry about how they interfaced with it through their application. As it happens, this was very early on in the development of the HMS safety board, so we helped Fortress with a lot more of their design than they'd expected to, and it's a service we offer for our clients, that we will work with them so they're not alone trying to integrate this solution. So we were involved in the tough testing and documentation, but at the end of the day, the pre-certification of the system really shortened the development time for them, because they could then just concentrate on certifying the complete solution and not having to worry about the safety module aspects of it. So I'm going to pass back to Kurt. Kurt's going to look now a little bit more into implementation of that kind of solution.
Thanks, Stuart. To show you an implementation, I would like to introduce two components we have available for that. That's first of all the XAT Safety-100 module, which is a pre-certified safety module with IOs for one safety relay and for one emergency button. And in this case, it's running Profi Safe. It contains of a two-layer credit card size boards. The lower layer contains the dual microcontroller solution with the stacks, and the top layer contains the safety I/O towards the emergency button and safety relay. It's connected to our Anybus Compact COM solution, a complete ready to use board to support real-time Ethernet, in this case Profinet. And the Anybus module will support for your application Profinet and exchange information to your application over the Profinet network, and passes all safety messages over the black channel towards the XAT Safety-100 to process it. To design in, the XAT Safety-100 is already pre-certified, but comes with a complete safety manual you have to follow to fulfill the demands of the safety organization. And that means that with help of the manual, you can implement it into your design, and that's important, you can write on top the complete product safety manual needed as the safety documentation of your implementation. And when you have done that, you can get rather quickly a certification by TÜV, and reducing the amount of time and the amount of investment needed quite drastically. To wrap up, we are using pre-certification communication module. They come as common hardware and software design in, which are completely focused on safety I/O, and they work together with all well-known safety PLCs. With help of those components, you can set up a rapid development. You get a proof. You have a proof design-in concept before starting. You can do your functional and technical development. Set up your product safety manual and do your validation, and finally get in a limited amount of time and resources a complete product safe approval. We thank you for your attention.
Thank you very much.
A great presentation. There's if people have questions, they can ask it in the chat. For now, we have one question about safety communication and wireless. Is it possible to communicate safety communication over wireless connection?
Yes. Wireless communication is as unsafe as copper communication. The only thing at wireless communication is that third-party organizations wants to see that the setup of the wireless is done in such a way that you can't alter it anymore. That means that the only way to alter it is setting up a factory reset. But by doing so, you can implement wireless without a problem.
Okay. And is there a possibility to add specified functionalities to a standard safety module?
Yes, of course it's possible, but please note, at the moment you change anything to standard components within the safety protocol handling, it means that you have to start your project all over again, which means that you miss the advantages of using pre-certified modules in the first place.
Yeah. Okay. There's another question about, is it possible to connect two networks together and using the safety solutions?
Yeah. Technically it's possible, but in reality it's almost impossible, because it means that you have to open the safety container, get the information out, and put that into the safety container of the other protocol, and to do that in a safe way, accepted by a safety organization, that will be very difficult.
Okay. Yeah. Okay, and there's another question about sharing the presentation. Is it possible to share the presentation? We can share it with you afterwards.
We will compile the presentation as a handout and add it to the environment.
Okay. We can also publish the replay of this presentation. Is that also for you guys okay?
Yeah, fine.
Yeah.
Okay, great. Thank you for sharing your knowledge to our visitors.
It was a pleasure.
That's fine.
Very good. Nice.
Okay.
After this presentation, we go on 2 o'clock and 3 o'clock with another. We start with another presentation. 2 o'clock, it's the title is 3D vision, and 2 o'clock was that, and 3 o'clock it is from machine to process. From the director of Trumpf, the machine builder. So if you want to register yourself, I will share a button right now. Yep. So there's a button. You can register yourself to the other presentation. Kurt and Stuart, many thanks.
You're welcome.
Thank you. Bye-bye.
Also in England, keep it safe.
We'll try.
Okay. Bye.
Okay.
Bye.
Bye-bye for now.